All right, so now I'm going to go through the chapter 17 through 19 study guide. So hopefully this will help you get ready for the test. So number one, catalog sales company promises to deliver orders placed on the internet within 3 days. Follow-up calls to a few randomly selected customers show that a 95% confidence interval for the proportion of all orders that arrive on time is 88% plus and minus 3%. So first of all, if I add and subtract 3%, that would bring me to from 85% if I subtract, or 91% if I add. So 85 and 91. Remember the definition of a confidence interval, the interpretation of the confidence interval from our notes says that we're not, in this case, we're 95% confident that the actual proportion or percentage is within the interval. In this context, that's going to mean that let's see, we're 95% confident that between 85% and 91% of all orders will arrive on time. So the one that closely says that is B. Okay. Number two, let's see. Explain same. So we're doing the same thing. Basically, explain what this confidence interval means. We're trying to estimate the fraction, again, we could say percentage of cars in the United States that are made in Japan. So it looks like our lower limit is 33% and our upper limit is about 51%. So in once again, this is a 99% confidence interval. So now we can say that we're 99% confident that the actual percentage of cars in the United States that are made in Japan is between 33 and 51. And which one is saying that is A. We are 99% confident that between this and this percent of cars in the United States are made in Japan. So A is the answer. Okay, an agricultural researcher hoping to increase egg production gives a food supplement to test a group of 275 hens and finds they now produce 210 eggs a day. Construct a 95% confidence interval. So we're going to go to proportion stats on StatCrunch. So stat, proportion stats, one sample with summary. And let's see, we have 210 out of 275. Whoops, what happened here? Must have accidentally. Okay, let's try that again. So 210 out of 275. And let's see, we're doing a 95% confidence interval. All right. And we're going to round to 3 decimal places. So it'll be 0.713 and 0.814, it looks like. Continue. So number 4. Number 4, we're going to do essentially the same thing. So we're going to go to proportion stats again. Okay, so now we have 4,844. Right, 4,844 out of 100,000 is our sample size. Okay, and we're doing a 99% confidence interval. So we're going to change that to 0.99. Okay, and there's our confidence interval. And now we're going to round to 2 decimal places. Notice this time they have percentage. So when you see the percent sign, that means convert it to a percent first and then round. So if I convert this to a percent first, this is going to be 4.67%. And the upper limit, let's move that over, it's going to be 5.02%. So again, when you see the percentage, convert it to a percentage first, then round. So there's our answer to number 4. Number 5, now we're doing a hypothesis test within proportion stats. Is the rate of twin births the same among teenage mothers? There was a question similar to this in your assignment. Remember, our hypotheses are either going to be less than, greater than, or not equal to. It's based on the wording of the question. In this case, it just asks, is it the same? Is it the same? That doesn't imply less than or greater than, which means it's going to be not equals to. Now we're going to go into StatCrunch proportion stats to find the p-value. So once again, stat, proportion stats, one sample with summary. Okay. And what was it? It was 11 out of 506. 11 out of 506. Our guess was 2.9%. So 2.9% is 0.029. And we had already said that our alternative was going to be not equal to. So here's our p-value. So that's 0.029. No, excuse me. Our p-value is 0.330. Okay. So remember, to determine which one is true and which one is not from our initial guess or alternative, we look at the p-value. If the p-value is if it's less than 5%, then that means our initial guess is false. In this case, it's greater than 5%. It's actually over 33%. So that means that our initial guess is true, and thus our alternative is false. So the not equals part is false, which means this is true, so they are not different. Okay, the equals part is true, which means they are not different. Okay. Number 6, same thing. Okay. Is this strong evidence that the risk has increased? The risk has increased. That implies greater than. Okay. And now we're going to do the exact same thing we did in the previous question. All right. So our sample size is 359. And the 35 of them showed signs of an abnormality. So 35 goes here. Our guess was 8%, so that's going to be 0.08. And we had already said that it was going to be a greater than. Okay, so now let's go ahead and find the p-value. Okay, round to 3, so that's going to be 0.111. Okay. So once again, our p-value is greater than 5%, so that means our initial guess is true, and thus our alternative is false. So it has not increased. There is not sufficient evidence that the risk has increased. Okay, so if our our null hypothesis is proved to be true, that automatically means our alternative is false, which in this case, it is not greater than, it has not increased. Number 7. After surveying students at a local college, a campus organization calculated that a 95% confidence interval for the mean cost of food for one term is this. How should the organization interpret this? So, once again, this means that we're 95% confident or 95% sure that the actual mean cost of food is within that interval. So the organization is 95% sure that the average amount a student pays for food is between those two values. So the answer is C. Okay. Now we're going to find a confidence interval, but this time we're going to go to T-stats. So T-stats, one sample with summary. Okay. So for a random sample of 44 weekdays, that's the sample size. Daily fees averaged $127. So that's the sample mean with a standard deviation of $17. Okay, and we want a 95% confidence interval. 95% confidence interval. So there is our confidence interval. Because we're talking money, we're going to round to 2 decimal places. So 121.83 and 132.17. Okay, 90% confidence interval this time. Again, going to T-stats. Whoops. Okay, so remember, N means sample size. So our sample size is 72. Okay. The one with the bar over it, that means mean. So the mean is 80.5. 000. And S stands for sample standard deviation. So 2.65079. And this time we want a 90% confidence interval. So make that a 0.9. Okay, round or 2, so that'll be 79.98 and 81.02. Okay. Number 10, hypothesis testing using T-stats. So the question is this strong evidence that the actual average gas mileage is lower than the goal? That implies less than. Okay, we're going to go T-stats again. One sample with summary. Okay. To see if the goal is met, they check the gasoline usage for 60 company trips. That's our sample size. Finding a mean of 23.36 NPGs. So 23.36 is your sample mean. Standard deviation of 4.98. So 4.98 is your standard deviation. Okay, we had already said that this was going to be less than, and remember our guess was 25. That was our goal, was 25 miles per gallon. So 25 miles per gallon and less than. Okay, so our p-value is 0.00 and rounding to 3, so that'd be 0.007. Okay, and last question, number 10. Oh, no, that was number 10. All right. So that is it. That is the study guide for chapter 17 through 19. Make sure you have done the assignment and that you contact me if you have any questions before the test.